Hi friends, this is Meera and welcome back to my YouTube channel. Today we will discuss how to find centroid of area of an unequal L shape. I am going to give you step-by-step procedure to solve numerical with a practical example in this video. But before we begin, I recommend you to watch my video on basic concepts of center of gravity and centroid so that it will be easier to solve numerical. You can find that video and my previous videos in I button above or a link in the description box below. So let's begin. Suppose you want to find out centroid of the balcony of your own home. Now we are interested in centroid of the cross-sectional area. So we will remove side parts. I am not advising you to do this cutting unless you have a spare balcony, okay? Now, if you are standing on the balcony, you'll be able to measure some of the dimensions. Like, you can measure the width of parapet or what we call guard wall. Let's say it is 18 centimeter in my case. You can measure the height too. Let's say it is 100 centimeter. Measure the width of balcony, that is the width of actual area available as balcony, say 202 centimeter. And with some difficulty you may able to find out the total height too, that is 118 centimeter for my balcony. Okay, please don't fall. Now the very first step is to find out all missing dimensions and locate the reference axis. Check for any missing data of width or height. So first missing dimension is total width of slab. We can find it out by adding all horizontal dimensions, that is width of balcony 202 cm plus width of guard wall 18 cm, which is equals to 220 cm. And another missing dimension is height of slab, which we can find out by subtracting height of guard wall from overall depth, that is overall depth of 118 cm minus 100 cm of guard wall equals to 18 cm. So here are all the dimensions we'll need to solve example. Now let's locate the reference axis. Place x-axis at the bottommost plane of section and y-axis at the leftmost section. Next step is to divide the whole area into more basic shapes whose centroid locations are known to us. I have mentioned in my previous video that centroid of some shapes are given in reference books like triangle, a rectangle, semicircle, quarter circle, etc. So you can directly memorize this and use in numerical to avoid tedious and lengthy calculations. For this problem, we will divide it into rectangles. You can divide the area as per your convenience like this or this. Centroid coordinates will be same in each case. You can try it yourself for any kind of divisions. Here we will pick any one of these two figures and find out centroid. Next one is an important step where all calculations will be made to find out required data. Before we start calculations, let me quickly remind you the equations to find out x coordinate and y coordinate of centroid. X coordinate is equals to sigma ai xi divided by total area and y coordinate is sigma ai yi divided by total area. So to find out centroid, we will have to find out area, x coordinate and y coordinate of all individual divisions denoted by I. In our case, There are two divisions and both of them are rectangles. So in general, area of a rectangle is width multiplied by depth, and centroid coordinates are b by 2 and d by 2 depending on the position of rectangle. Also, here all dimensions are in centimeter. So unit of area will be centimeter square and unit of x and y coordinates will be centimeter. Now let's find it out for rectangle number 1 or the slab. Right now we will just focus on slab and ignore other rectangle. Locate centroid and dimensions of rectangle 1. So area of rectangle 1 is 220 cm multiplied by 18 cm, that is 3960 cm square. The most important step is to find out x and y coordinates of individual shapes. It becomes very easy to find out centroid if you know how to find the coordinates correctly. We know coordinates of rectangle are width by 2 and height by 2. X coordinate of rectangle 1 is dimension in x direction, which is 220 divided by 2, that is 110 centimeter, and y coordinate is dimension in y direction, which is 18 divided by 2, that is 9 centimeter. Now check out the location of reference axis with respect to the selected rectangle. As per reference figure, both x and y axis should touch the planes of rectangle. Here in our case, both axes are touching the plane. So final coordinates will be same as previously calculated data and no alterations needed. We will repeat step number 3 for other rectangle. So first we will highlight rectangle 2, that is guard wall or parapet, and locate centroid and dimensions. Now area of rectangle 2 is 18 cm width into 100 cm height, which is equals to 1800 cm square. X and y coordinates for rectangle in general are width by 2, that is 18 by 2 is equals to 9 cm, and height by 2, that is 100 by 2 is equals to 50 cm. Now these individual coordinates of rectangle can be considered as final coordinates if x-axis and y-axis are touching the plane of rectangle. But it is not the case here. As you can observe, x-axis is some distance away from rectangle 2. So we have to add this extra distance to previously found coordinates of shape. Now this distance is equals to height of slab. So we can find out final y coordinate by adding height of slab, that is 18 cm, to previously found y coordinate. So area is same. Final x coordinate x2 will be same 9 cm as y axis is touching the plane. And y coordinate y2 will be 50 plus 18 equals to 68 centimeter. So that's it. Let's sum up all the data of area, x coordinate and y coordinate we have just calculated. We just need to input these results in the equation of centroid of an area. So to find out x coordinate of centroid, we'll take moment of area with respect to y-axis. So total area moment will be equal to summation of moment of all individual areas. Or you can memorize this equation directly. We already have the values of a1, a2, x1 and x2. So put all values and we will get x coordinate equals to 78.43 centimeter. Similarly, y coordinate of centroid can be found out by taking moment of area with respect to x-axis. So moment of total area will be equal to summation of moment of all individual areas. Put values of a1, a2, y1 and y2 in this equation. So y coordinate we get is 27.44 centimeter. And here is the centroid of your balcony.